splits into this procedure. We do a lookup. If we didn't find this record, then we're going to go into a loop. While ID is 0, we didn't find a record, and max tries is greater than 0. Max tries starts at 127, so what are we going to try 127 times? We're going to try an insert statement. Have you ever seen an insert statement fail the first time and then work the second time? I have never seen that happen. If it fails the first time, you know what's going to happen the second time? It's going to fail again, and again, and again, and again. And they use that at Reddit when others then null, which basically says, no matter what error happens, just ignore it. We're going to try this 127 times. This is a great way. Oracle should promote this programming technique because you're going to need a lot more CPUs to run your system if you do this often than you do without it. And since we license by CPU, I would like to see everyone write this code. Right? I would prefer you do it the right way. Less code, less bugs. We love writing really cool code. So here's somebody who hasn't bothered to read the documentation or learn a programming language at all. They have a very simple question. How can I change the sign of an integer? I want to convert -12 to +12. That's the simplest thing to do in any programming language. N equals -n. That pretty much works in every single programming language. Well, people got a little sarcastic and said, this sounds like a very hard problem. Here, try this. This absolutely works. Let's just loop any number of times and decrement it or increment it, depending on the sign of it, and make it go up or make it go down. It absolutely works 100%. Here's another one. We could use some 2's complement arithmetic. We all learn this in computer science, right? So we can take the OR of the number with all these ones and add ones to it. We just use 2's complement arithmetic, and it changes the sign. Absolutely works. It's probably relatively efficient, too. It's much more performant than the loop that happened before, but it's perhaps even less clear what it's actually doing. So people just kept coming up with different ways to do this. Here's shorthand. This one looks much more fancy. Let's just use the tilde in this language. That's the negate operator. Or even better, we could use that one. Right? That will work. Let's take away one and then negate it, rather than negate it and add one. So there's a different way. And they just kept coming up with all of these algorithms over and over and over again, showing that there's always a simple way to do something and really, really complex ways to do it. So if you're looking at a problem and you find yourself generating a ton of code to solve this problem, it might be time to take one step back and ask someone else to look at it. And they can come up with a really simple way to do something. Because the problem as software developers, once we get very close to a problem, and we've been staring at it forever, we get stuck with our approach to solving it. And we don't see those other approaches. So bringing in others and asking them to take a look at it is sometimes a good idea. You can reduce 1 million lines of code to a single statement if you know how. I'm not going to read this article. It's a long one. And by the way, I will make these presentations available to you. You'll have all of these referenced URLs and web pages, so you don't have to write anything down. But reading through this article, I read it, and I liked a lot what the author was saying. They were talking about different languages, different tools, how different tools approach problems in a different way. And he came to the conclusion that SQL is a lot like all of these tools. SQL has a very specific approach to things. SQL works in sets. Procedural programmers aren't thinking in sets. They're thinking row by row, for processing loops. Right? SQL, you got to think in sets. What this author went through and wrote, I paraphrased, was to be a good SQL developer, you have to be able to think in terms of sets and algorithms, procedural algorithms, at the same time. It's not just enough to come up with something that gives you the correct answer. Think of that. I need to turn negative 12 into positive 12. I can come up with an algorithm that does it procedurally. It's not the right answer. You should be looking for a different approach. When you're dealing with a SQL-based database, it's not good enough just to come up with a good algorithm that transforms your set as you need and try to force this procedural row-by-row approach. The SQL database servers aren't good at doing that. What you need to do is come up with a set-based approach, be able to understand how the database is going to interpret or process that so that you can make sure you write a query that matches the algorithm you have in mind. What if you want to get back 25 records to an end user and put it on the screen as fast as possible? You're going to index your data, you're going to organize your data, you're going to write your SQL statement differently than if you wanted to go against the same set of tables and get 25 million records back from that. You're going to have to think about what you're trying to do, how you would approach it, and how the SQL statement you're writing would help you achieve that goal. And he called it double thinking. He says you need to sort of double think procedurally and set-based at the same time. And if you can do that, you'll be able to harness all the power of SQL at that point. You'll be able to get rid of a lot of code and do things much more efficiently. Another big problem. We pretend everything will be all right. In other words, we are in a constant state of denial. Errors, they don't happen. Errors are something that happen to someone else. They don't happen to me. Here's a couple of cut and paste screenshots that I've accumulated. This is a blog written by a technical professional. He had to put up a web page that said, sorry, I experienced 100% data loss at our hosting provider. I do have some backups off to the side. I'll try to get it up and running. And it turned out he actually lost a lot of data. And when this happened, I wanted to see what this person had written about backup and recovery. So I did what a lot of people do when a web page goes missing. I used the Google cache to pull up an old image. And I searched an old image of his website for backup and recovery. And here he was just a little while before, a year before this happened, writing about, hey, you gotta back up. You have to think about backups. You have to think about backups way beforehand. If you can't recover, it's your fault, not their fault. He had to blame his hosting provider, right? Because he didn't know how they backed up. He had some backups on his hard drive. He was able to rebuild his website, but he had to go through a big problem, big involved recovery process in order to do this. He wasn't following his own advice. It could never happen to me. That's what he was thinking. I'm living a much less stressful life for the last 3 or 4 months, because about 3 or 4 months ago, I moved AskTom from a server I managed to a data center. It's now being managed by a team of DBAs. Their job is to back it up, recover it, and make it available. It's not my job anymore, but I know exactly what they're doing and how they do it. And I know that they're doing it in a good way, and I know that it's happening constantly. It's much easier for them to provide me that service than me to do it, but that's a pretty big deal. If I lost AskTom, if AskTom got wiped out, I'd probably have to quit, because all of you would make fun of me forever. I would never be able to recover from that, because I'm a database guy, right? And I write about this backup and recovery. But it happens all the time. Here's another one. This was the second largest site of its type. It was a BitTorrent streaming site. It was in the Alexa Top 500. It had a lot of traffic. And then it died. And they had to put up this page that says,